Hi, everyone, and welcome back to another episode of Science. In this episode, we're taking a look at motion, specifically how to calculate speed, distance, and time. This is the beginning of our topic, so at the beginning of new topics, we always ask new questions. Why do objects speed up as they fall to the ground? Why a boomerang comes back? Why you sometimes feel heavier than usual traveling in an elevator? And why is it hard for a heavy truck to stop quickly compared to a much smaller vehicle? These are just some of the questions that we'll be able to answer by the end of the topic. I've got an interesting little video for you here. If you want to load up the PowerPoint and click on this link, it'll take you to an astronaut who dropped a hammer and a feather on the moon. Pretty cool, check it out. But let's begin. We start with two new terminology words, distance and displacement. Distance will give you a particular size, a number, but it won't give you a direction. Displacement is a value which will give you both a size, a number, and also a direction. For example, left, right, up, down, north, south, east, west, and any combination of those. Let's take a look at what I mean. I've got two diagrams here, one showing the distance traveled and one showing the displacement between two objects. On this diagram here on the left, a student starts at home, and in order to get to school, the student must zigzag their way through the streets in order to actually make it to their school. And they travel a particular distance, 0.5 kilometers here, 0.5 kilometers here, here, and here. And so Greg, the student, walks to school and travels a distance of 2 kilometers. Taking note that distance does not include a direction. If I compare that to displacement now, displacement is the straight line distance between the home and the school, which in this case is about 1.4 kilometers. But for displacement, you need a direction as well. So Greg's displacement would be 1.4 kilometers northwest. It is the straight line distance and an additional direction piece of information that we refer to as displacement. Whereas distance, it's the distance traveled in order to get to your destination, and it does not have a direction involved. Displacement, straight line distance plus the direction. Let's get moving forwards. Now within motion, you'll have to do a fair bit of conversion actually, and we use the standard international units, which for us is just the metric units. So it makes our life much easier using these metric units. Most of the world uses metric units except for America, who still uses the imperial system. So for length, we'll be using meters and kilometers, which is shown by M and km. For time, we'll be using seconds, shown by S, and hour, shown by H. When you're taking your notes, I would highly recommend you incorporate this diagram into your notes. It will help you with converting. You'll need to convert often within this motion topic, going from kilometers per hour to meters per second, and then back to kilometers per hour. In order to go from kilometers per hour, which is the distance traveled in this time, you divide it by 3.6, and that will give you your speed in the meters traveled every second. And then if you multiply that by 3.6, it takes you back to kilometers per hour. Divided by 3.6 takes you to meters per second. So this little calculation will be very important to you. Definitely take note of it. Okay, so let's do a bit of a practice here. So a cheetah, we want to work out the meters per second, and we're given the kilometers per hour. So the cheetah is able to sprint at 102 kilometers per hour. We want to calculate the meters per second. If we come back here, speed in kilometers per hour, and if we want to go to meters per second, we need to divide it by 3.6. So I would do 102. I'll just punch it into my calculator here now. I would do 102 divided by 3.6 equals 28.3 meters per second. And always write the units down. You will lose marks if you don't incorporate units, so just get used to it and make sure you always write down the unit for the answer as well. Go ahead and practice for these other ones. You can check your work with just an online calculator. I won't do all these for you, but definitely check your work at the end using an online conversion calculator. Pretty straightforward though, you're just dividing or multiplying by 3.6. Okay, let's take a step forward from here. In this topic, we're going to be calculating average speed for a particular object. And in order to do that, we do a simple division. The distance traveled divided by the time, also shown as v equals d over t. Speed equals distance divided by time. Speed is just a measure of how quickly something is moving. We can also calculate distance, and we even have a triangle formula for these calculations. This triangle formula helps us to calculate distance, speed, and time, and use different parts of the triangle depending on what you want to calculate. For example, if you want to calculate the distance of an object, you would do speed multiplied by time. If you want to calculate the time taken of an object, you would do distance divided by speed. If you want to calculate the speed of an object, you would do distance divided by time. And I've got the formulas here on the right hand side for you to take note of as well. Distance equals speed multiplied by time. Time equals distance divided by speed. Speed equals distance divided by time. Okay, here, pause the video and take some time to work out the solutions to these problems. I'll speak through the answers in just a moment. So pause the video here and see if you can work out the answers for each of these problems. Okay, assuming you've paused the video and you've tried to work out the solutions to these questions, now let's take a look at them one by one. An object is traveling at 15 meters per second for 10 seconds. What is its distance? When you're in a test or exam, the first thing you should do is look at the units and see if they actually match. In order for your calculations to work, the units have to match. So, for example, meters per second and seconds, 10 seconds here, the units match. And so if the units are matching, you can proceed with your calculation. After using your triangle formula up here, you should have ended up with an answer of 150 meters. 150 meters. This question, an object covers 20 kilometers in 30 minutes. What is its average speed? So for this particular question, you may or may not have noticed the two different units. I'm using kilometers with minutes, which doesn't quite work out. You need to use kilometers. Oops, it's not showing it. You need to use kilometers per hour or meters per second. Or for these minutes here, you need to use hours or seconds. So you would have either 0.5 hours, or you would have 1,800 seconds. So you need to convert either of these two numbers so that the units match. Either do 20 kilometers and 0.5 hours, or do 20 kilometers, which would be 20,000 meters, and instead of minutes, use 1,800 seconds. So you need either the units kilometers and hours or meters and seconds. Once you've converted either one of these two, this one either into meters, this one either into hours or seconds, you should have had an answer of 40 kilometers an hour or 11 meters per second. Let's have a look at the next question. Trin rides her bike with a constant speed of 5 meters per second. Okay, so our unit here is 5 meters per second. It takes her 3 minutes to get to the milk bar. Calculate how far away it is. So in this case, we're using minutes and meters per second. So the units, once again, don't match. From here, I would recommend converting this 3 minutes into seconds, keeping in mind that there's 60 seconds in 1 minute. So 3 minutes would be 180 seconds. And using the formula from before, using seconds and this 5 minutes per second, you should end up with an answer of 900 meters traveled. And because we're just asking for a distance, how far away it is, we don't need to give a direction. We're not asking for the displacement. While Trin is riding, a toddler runs onto the road ahead. If Trin took 0.5 seconds to react, how far does she travel before hitting the brakes? Well, if you know you're traveling 5 meters every second, how far will you travel in half a second? And the answer to that is 2.5 meters, half the distance. Hopefully that made sense. If it didn't, I would recommend trying to find some extra practice questions in your textbook, for example, or Google always has practice questions relating to this. You should also come to class and receive a goodness booklet from me with some more practice questions on these calculations. Let's move ahead and look at a couple of graphs here. On this graph, I've got distance on the y-axis and time on the x-axis. The first thing you should take note of is, are the units matching? So I've got meters here and I've got time in seconds here. Meters per second, my units match. That's good. Otherwise, this needed to have been kilometers per hour. If you had kilometers here and seconds here, the units don't match, so you would have to do a conversion. You would have to convert one of these units. I would recommend converting the kilometers. If this was kilometers, I'd recommend converting into meters. But in this case, it's done for us. It's matching units, meters and seconds. We can move ahead. When you see a distance time graph like this, you can do a calculation to find out the average speed that this particular object was traveling. And we do that with a rise over run, a rise divided by a run. For this particular graph, the rise is 30 meters. 30 meters divided by the run. The run is this x-axis here all the way to 6, so 6 seconds. And if you do 30 divided by 6, you should end up with the answer of 5 meters per second. 5 meters per second. So that is the average speed of this object. And you can calculate it on a graph using rise over run. The final thing I'd like to show you is a speed time graph. This time, let's have a look at our units quickly. So on the y-axis, I've got meters per second, and on the x-axis, I've got time in seconds. Good, my units match, so I don't have to worry. I can proceed with my calculations. Calculating the area below the graph reveals the distance traveled. So if you have a graph which tells you how fast you are traveling over time, and you calculate the area underneath the graph, that will tell you how far the object has traveled. Let's just have a closer look at the line of the graph though and have a discussion as to what this object is doing. First of all, the object is accelerating for section A here. This is an acceleration. The object is getting faster as time goes on. And then in section B, the object is moving with constant speed. In section C, the object is once again accelerating. And in section D, the object is decelerating and comes to a stop. And I would encourage you to use those terms: acceleration, deceleration, and constant speed. Those are motion terms that you should get used to using. From here, now that we know what our object is doing, accelerating over 10 seconds, constant speed over 10 seconds, acceleration over 10 seconds, and deceleration for the final 20 seconds, coming to a stop at the 50th second, we can calculate the area underneath the graph and figure out how far this object has actually traveled. And from here, it's fairly simple. You have to find the area of this triangle, find the area of this rectangle. For section C, I would recommend dividing this section into two. So I've got a rectangle here and a triangle here, and D is a larger triangle. So I'd like you to find the area for each of these sections and figure out what the answer is. Write it down, pause the video here, see if you can work it out, and in a moment I'll just reveal the answer. So assuming you have paused the video and you've attempted to calculate the area of each of these sections, hopefully you have arrived to the answer of 675 meters is the distance that is traveled. From here, you should have received a speed, distance and time goodness booklet from me. Keep practicing using those practice questions. And Education Perfect, of course, always has some resources for us. Thanks for watching another episode, and I'll see you next time in class.